students. Today I am starting a first chapter, some basic concepts of chemistry. Okay. So first of all we should know what is the meaning of the chemistry. Chemistry is a science which is study about the elements, compounds formed by them. You all know these things. It depends upon the electrons. This is the chemistry. Chemistry may mainly used in the industries and the agriculture. Chemistry is used in the medicines. You all should know this thing. Chemistry and environment gradation, it may use in environment also. We have studied in the 9th standard. Actually the 11th and the 9th little bit something is equal. Okay, so we are talking about the matter. Matter, you know that having a mass and occupy space, that is a matter. Like book is occupying a space and having a mass, that is called as a matter. Now matter is of three types. We can say solid, liquids and gases. So what I am telling to you, these things you have to write it in your copy. So this is the table, solid, liquids and gases. These are the properties, what is the shape here, compression, hardness, arrangement of particles and diffusion. Right? So this is the properties of solids, liquids and gases. Next we are doing what is the interconversion of states of matter. Interconversion of states of matter may take place by three states, solid, liquid and gases. Solid is heating to give liquid and liquid is heating to give a gas. Gas is cooled to become a liquid and liquid become cool to become a solid. This also we have studied in the 9th standard. Now classification of matter may divide into two types. One is pure substance and second is a mixture. Pure substance means consists of particles of same kind of atoms and molecules takes place. Right? Next is what is the meaning of the pure substance. Pure substance can be classified into elements and compounds. So first of all, what is the element? There are 118 elements are there total. They exist in atoms and molecules. They consist of only one type of atoms. Various examples are given here. Next about the atoms. Atoms are smallest particles of element. Okay, so these are the examples of atoms. Molecules, two or more atoms are joined together to form a compound. Okay, some elements exist as a molecules, as these examples. Compound, two or more things joined together to form a compound but in a fixed ratio, that is a compound. Okay, so these are the properties of the compounds. Next is mixtures. Mixtures are two types. One is homogeneous, second is heterogeneous. So mixtures in always more than two things are there. It is not fixed also. Mixtures, composition is not fixed also. Beta, these things you have to write it in your copy. Okay, as fast as possible we will do these things. So these are the properties of the mixtures. Examples, sugar solution, here brass, is all things is a mixture may takes place. Okay, now it is of two types. One is homogeneous and second is heterogeneous. Homogeneous means the same thing, means fully dissolve, and heterogeneous means not fully dissolve. As an example, we are taking a chalk and water, not fully dissolve. Homogeneous mixture, we are taking a sugar solution, salt solution, that is a homogeneous mixture. Fine. Next is the properties of matter and the measurement. We can measure it by the physical and the chemical property. Physical properties means what is the density, boiling point, melting point, color, solubility. These all things is coming in physical properties. And chemical properties, chemical reactions are there. As example, acid base react together to form a salt, like these things. Okay, so these are the properties of physical properties and chemical properties. Next is measurement of physical properties. How we measure the physical properties? By its length, area, volume, melting point, boiling point. By this we are measure the physical properties. After this, let's study the SI units. Full form of SI unit is System International. It is word come from the French. Okay, so these are the units. You can learn these units and write it in your copy. Mass, you all know what is the meaning of the mass. Mass always remain constant. It is amount of substance present in it. SI unit is kg. Gram is used for small unit amount. Okay, gram is used for small amount and kg is used for the bigger amount. Next thing is weight. Weight, it is a force exerted by gravity on an object. It determined by spring balance. Its SI unit is weight. Let's take same thing as we are talking about the volume. How much volume it's occupied, what is the SI unit, these all things is written here. Next is density. Density, it is defined as the amount of mass per unit volume. Means here we are taking the two things, mass and the volume. SI unit is this density, kg meter, CGS gram centimeter cube. Here kg meter cube, gram centimeter cube. Okay. Next we are talking about the temperature. Temperature may takes place by the three things, Celsius, Fahrenheit and Kelvin. Okay. Now next we are talking about the thermometer. Thermometer with Celsius scale from 0 degree to 100 degree. 0 degree to 100 degree. So what is the formula over here? The formula over here is Fahrenheit is equals to 9/5 C plus 32. On a C side, what is the number given to you? What is the value given to Celsius? That value will come here. Okay. So here Kelvin may takes place plus 273. What is the Celsius? Let's for an example 20 degrees Celsius I have given, and I am saying this Celsius you have to change into the Kelvin. For that Celsius 20 you have to add with 273. The answer will come, okay, in Kelvin. So these are the temperatures. Scientific notations are given here. Important, these two things are there, precision and accuracy. Precision means it refers to the closeness of the set of values obtained from identical measurements of quantity. It refers to the closeness of the set, close things. Accuracy of a single measurement means single measurement we have taken, that is an accuracy. Okay. So this one table you have to make it, this one relation between various units. Fine. Then rules of determining significance. These rules here you can write down. Don't write the dimension analysis. Next we are talking about the laws of chemical composition. First law that is law of conservation of mass discovered by Anthony Lavoisier. They are said that matter can neither be created nor be destroyed. ना ही बनते हैं ना ही बिगड़ते हैं. Means the total mass of the reactant is equals to the total mass of the product. For an example, if here is for 50, then here is also 50. Here you can see 32 plus 12, 44. Here also 44. Means both the sum of things are 44, 44. So this is tell about the law of conservation of mass. If we will not use this example, we can use another example also. If we are using here 100, both the things are 100. Then here also in the product side we are using 100 gram. That's why they both are equal. This is the law of conservation of mass, which cannot be destroyed nor neither be created nor be destroyed. Next is law of constant proportion. These all things we have studied in our 9th class. That's it only. It is prepared by any method contain the same element, the fixed ratio. It is in a fixed ratio. Law of multiple proportion is left in the 9th standard, so it is coming here now. When two elements combine to form two or more chemical compounds, then the different weight of one of the element which combined with the fixed weight of another bear a simple ratio of one another. Means is this, when the two elements are joined together form a big compound, okay, and that big compound combined with a fixed weight, okay, their fixed weight is there. For an example we are taking as H2O, means the ratio we are using 1:8. So same condition is applying here in law of multiple proportion. Okay, examples, various examples they have given, you can write those examples. Next is important, Gay-Lucas law of combining value. Whenever gases react, they do so in volume and bear a single ratio if they are at temperature and pressure. So hydrogen react with chlorine to form HCl. 1 liter of hydrogen combined with 1 liter of chlorine to give 2 liters of HCl. Fine. So in this one what you have to learn? You have to learn these things, that who has discovered and what is the meaning of it. The meaning of it is this, that when gases react, the volume goes in a simple ratio. Okay. Avogadro number. In a Avogadro number, equal volume of all gases under similar conditions of temperature and pressure. Equal volume will take place of temperature and pressure. Okay. Here we are using a standard temperature also. Standard temperature here we are using in Kelvin, that is 273 Kelvin. Okay. And equal number of molecules will take place at that time. We are using in a liters, that is 22.4 liters. Actually it is given from the book. From its starting the scientist has introduced 22.4. We will not change these things. Okay. Next is Dalton atomic theory. This already we have studied. These things you have to write down in your copy. Now next is atomic mass. Relative atomic mass defined as in heavier than 1 upon 12 of carbon units. Okay, this is the atomic mass. Now atomic mass unit is always be taken by the carbon 12 isotopes. Okay, we can say as carbon 12 always. It's means it is a comparison will takes place with the carbon 12, and it's a new symbol. We can say mu. This U is said to be the atomic mass unit, or you can write down AMU also, or you can write down this also. Fine. Now next is average atomic mass. Average atomic mass means when an element exists as isotope, that is atoms of same element with different atomic mass. Means element is remain same, but its atomic mass is different. That is said to be the average atomic mass. Fine. So let's take example of average mass of carbon. Carbon we are taking as 12. Carbon we are taking as 12 now. So here they are finding out average mass of carbon. Now next is molecular mass, formula mass. This already we have completed. Okay, same condition is applying here. They are doing the comparison with carbon 12. Fine. Here we are starting the mole concept here. Mole concept is important. A mole is the amount of substance that contain any atoms, molecules, ions or other particles. Okay, they contain any atoms, molecules or ions. Next is Avogadro constant. Avogadro constant, we are using a value here 6.02 to 10 to the power 23 particles per mole. It is denoted by Na. Okay, when we have to find out the number of atoms in moles, then we are using like this 12 grams, that is of carbon, and 1.99 the mass we have taken from the carbon, that is, and this is the number of atoms which is in a 1 mole. Okay, so first of all, when we doing any numerical, we will write like this: 1 mole of hydrogen contain this much hydrogen molecules, 1 mole sodium contain this much, ethyl contain this much, carbon is 12 gram, Na is 23, this is the mass, and alcohol is 46. Okay, so now conversion, these are the things in which you are using a numericals. So number of molecules here we are saying as number of atoms upon Na. Na is the Avogadro number we are using. Number of moles, when we have to find out this one formula we have to put. Number of atoms is when the number of atoms we have to find out, we are using this formula. Number of molecules we will do, then we have to use this formula. Fine. Next is percentage composition by the mass percentage and the volume percentage. Okay, mass percentage is mass of element in a compound with the molar mass of the compound into 100. Now here we are using an empirical formula, in which the empirical formula various numericals are also there. In an empirical formula, the formula which represents the simplest whole number ratio of various atoms present in a compound. In this one we are using a whole number ratio in empirical formula. When I am going to do the numericals now, then you will understood properly. Molecular formula, the formula which shows the exact number of different types. Means here different types of elements are there, but exact number we have to use. That is the molecular formula. Empirical formula means simplest whole number ratio we are taking of various atoms. That is the empirical formula. Now what is the relationship? Relationship molecular formula and empirical formula. Molecular formula is equals to this one. N is coming out molecular mass upon empirical formula. This is the relationship of both the things, molecular and empirical formula. Now next is what is stoichiochemistry. It deals with calculation of masses of reactants and the product. Okay, stoichiometry means we are dealing with the reactant and the product. So how we balanced it? When we are balanced the chemical equation, both the things should be remain same. Reactant is equals to the product. Fine. Now next is this limiting excess reagent, nothing is there. Don't write these things. Limiting and excess reagent. Fine. Now here molarity already I have told to you in solution chapter. Sorry, I have not told to you molarity. What is the meaning of the molarity? Here we have studied in the 12th chapter, that is the solution chapter. Molarity is the number of moles of solute dissolved per liter of solution. Means number of solute is there with the per liter of the solution, that is the molarity. Mass percentage is solute upon solution. Amount of solute, amount of solution. Molality means number of moles of the solute per 1000 grams of the solvent. Right? means is this number of moles of solute per thousand grams of the solvent. Fine, solute upon solvent. WB we have taken as a solute, and MV we have taken as a molecular mass of solute, and WA we have taken as a mass of solute. These things only formula are there so that you can find out the numericals how we have to do. Mole fraction is important. It is defined as a ratio of number of moles of a component to the total number of moles of all components. Here we are taking the total number. First of all, X is equals to Na plus Nb, XB, Nb, Na plus Nb, Xa plus Xb is equals to 1. Okay. Now next is strength of the solution. These various formula of the strength of the solution you have to write it in your copy. That is when the volume they are asking which formula we are using, weight volume which formula, only molarity they are asking which formula, molality which formula. Okay, so and here when the word came D for the density. Okay, now next, these things only you have to write it in your copy. Parts per million. In a parts per million we are talking about number of parts by mass of solute per volume of the solution, means M1V1 is equals to M2V2. Fine. Molarity of two solutions of same type of substance we are using like this: MV1V2, M1V1V2, M2V2. Fine. So this is the formula which you have to use in the numericals. Fine. Here XB we are taken. For a XB we are say as this is the number of solute, this is the number of the solvent per kg. Okay, this is also the number of solute. So if anything we have given to you, for an example, here we are putting 1,000, then here also we are putting 1,000, and here that value that we are giving in the copy, that value we have to put. So this is we have to find out the mole fraction of it. These things you have to write down in your copy. Okay, now one question arises here: calculate the mass percentage of different elements present in sodium sulfate, that is Na2SO4. So we have studied 9th standard how we have to taken out 2 into Na plus S plus 4 into O. We have to put these values, and then 142 U came. Now singly we have to find out the percentage of Na, S, and O. So that formula we are using, which I have said to you right now. So exact formula that we are using, that is mass of element upon mass of the molar mass of the compound. So percentage, only one I will tell to you, rest you know very well. Percentage of Na, that is 23 is the mass of it. Total mass of sodium is how many atoms? 2 atoms are there, that's why we are putting here 2 into 23. And here 142 which is coming at the last, that is molar mass of Na2SO4, that is 142 into 100, and this is the percentage. In all these things we are doing like this only. Okay, next is the